Alright, so for two-step equations, it's pretty much the same thing as one-step equations, except now we have a second step. So instead of just rocking and rolling on one step, we have added in that second one. And it's really not any more difficult, it just looks like there's more to it. We only really add one rule in here, and we'll get to that in a second. But like I said, today, the date is April 16th, 2010. Wonderful day. Wonderful yellow slide up here as well. It's good stuff. Okay, so for our rules for two-step equations, that first one, always add or subtract first. This is going to fly in the face of everything you've learned mathematically so far. You're always going to want to add or subtract first. Which means if you have an opposite operation that's addition or subtraction, you're going to do that before you would do an opposite operation that's multiplication or division. On one-step equations, we did one opposite operation per problem. Now we're going to deal with two oppo-oppos per problem. Okay, does that make sense?
Yeah.
Okay. So we do addition or subtraction first. We're not going to change the numbers, and we're going to use the opposite operation. Those last two rules in there are the same as the ones that we've been doing.
Do you ever change the numbers?
No,
But can't you change
not
it?
at this point.
Can't you change it if you do addition or subtraction?
We're not going to change, as far as keeping the sign positive or negative, we're not going to change the sign. That's what we're getting at.
I thought you meant like going from 3 to 2.
Yeah, also don't do that.
Yeah.
Don't ever change the value of a number either.
That'd be pretty weird.
We don't have the power to do that. Alright, next slide. So let's look at our first example here. Notice that instead of just maybe 4x equals 23 or x plus 3 equals 23, now we have two things going on. We have multiplication with 4 times x, and we also have addition with that plus 3.
PEMDAS.
Okay? PEMDAS would apply here, but except we're going to do it backwards. When we're solving these multi-step equations, two-step in this case, we do our order of operations backwards. So it's PEMDAS backwards.
So DAS.
Yep. We do it all backwards. So in this case, if we're going backwards, what would our first opposite operation be? Molly?
Add or subtract.
We would subtract. Because we're adding 3 there, now we're going to subtract. So I'm going to write my line because we got that equal sign going on. And I'm going to subtract 3 from this side and 3 from this side. We're subtracting 3 from the entire left side and from the entire right side. So 4x plus 3, now minus 3, means that we're canceling out these 3's and we're left with 4x equals 23 minus 3 is 20.
So we just keep rewriting it?
Yes, ma'am.
So it's
Now we're left with 4 times x equals 20. What's our opposite operation here? Division. And remember, we talked yesterday about doing a fraction bar for division now instead of that little percent looking sign thing. So now it's 4 times x divided by 4 equal to 20 divided by 4. These are going to cancel out again, and we're just doing everything we can to isolate the variable. What is x going to be equal to after we divide? 5. And where plugging in our answer to check our work seems kind of silly on one-step equations, it's a little bit more important on these ones now. When you add a step, you add a place where you might mess up. That's why we check our work. So let's go ahead and check this one. If we're going to plug 5 back in there all the way at the top, if I can get the arrow there, for x, it's going to be 4 times 5 plus 3. Make sure you're writing down everything I write down here. 4 times 5 plus 3 should end up equaling 23. Let's see if that's the case. Now we do PEMDAS in the right direction. Since we're not solving it, we're going to do PEMDAS forwards. 4 times 5 is 20, plus 3 equals 23. And then we keep solving it, keep going down. 23 is equal to 23, which means this checks out.
So PEMDAS is SADMAP.
Sure. Yeah, SADMAP. We're going to do PEMDAS backwards. And especially on these two-step equations, the main thing to remember, add and subtract first, if that's your oppo-oppo. And then multiply and divide second if it's your oppo-oppo. Any questions so far? Does this feel like it's that difficult? Okay, let's try this one. Number 2 says b divided by 4 plus 5 equals 6. b divided by 4 plus 5 equals 6. I see that equal sign, so I'm going to draw a line down here. Now remember, think about what we have to do first when we're solving these equations.
Draw your line.
We already drew our line. Bailey?
You have to subtract 5
From where?
from your 5, and then you have to subtract 5 from your 6.
Very good. We do our opposite operation, that's either addition or subtraction first. Then we go through with the other of multiply and divide. So, b divided by 4 plus 5, all minus 5 means these 5s are going to cancel out. And we're going to be left with b divided by 4 equals 6 minus 5 is 1. So now we're left with pretty much a one-step equation. Some number, b divided by 4, is going to give us 1. So let's solve again. What's my oppo-oppo of what I have left?
Multiplication.
Yeah, very good. Multiplication. So I'm going to multiply both sides by what I have left, which is 4. b divided by 4 times 4 means these are going to cancel out. And I'm left with b equal to 1 times 4 is 4. Awesome. What do I do now?
Check.
Yeah, very good. Check my work. So I'm going to put 4 way back up there into b. And it's going to be 4 divided by 4 plus 5 should equal 6. Let's see if it does. 4 divided by 4 is 1. 1 plus 5, yeah, it's 6. So that checks out.
Wait, are you doing the star for 4 now?
For multiplication.
That's multiplication. Are you talking about these right here?
Yeah.
Those mean multiply.
But like, are we doing a star now? Like, because we did a fraction bar for division.
No, you can do x. I'm just doing that so it doesn't look like x4. That way we definitely know that that means multiply. All right, any questions? Okay, let's move on to the next slide. This one we have 5 times x minus 9 equals 36. 5 times x minus 9 equals 36. First thing I need to do is what? Okay, I separate them. And I do that by drawing the line. If I have my equal sign here, I'm going to draw that line so that I separate both sides of my equation. I know whatever has to happen on one side has to happen on the other as well. So, first rule of two-step equations is what, Ryan? Alright. We do our opposite operation of addition or subtraction first. So what are we adding to both sides, Ryan? 9, very good. So I add 9 to both sides. These 9s are going to cancel out, and I'm going to have 5 times x equals 36 plus 9.
Wait, are you always gonna do the number on the side first?
Not necessarily.
Okay.
That's like we talked about earlier, where we could rewrite the equation and flip it in case it doesn't look right to us.
Okay.
No matter what, we always do the addition or subtraction, oppo first. Right, so we're left with 5 times x equals 36 plus 9 is going to be 45. Now, what's my opposite operation, Deja? Divide. What am I dividing both sides by? Yeah. Remember, our goal is to get x all by itself, so we have x equal to 45 divided by 5, which is 9. Check my work. 5 times 9 minus 9 should equal 36. 5 times 9 is 45. 45 minus 9 is 36. That checks out. So far, so good? Alright, I want you to try this one with your C partner. J divided by 2 plus a negative 3 equals 15. Try this one with your C partner.
Yeah, you subtract. Put it in the constant. 15 minus -3. So that was right.
Alright, if you finish, you can check your work up front.
Oh.
According to what I did, I got 15
Oh, yeah.
equals 15 down there after I checked, and that's after J is equal to 36.
We're good.
So J should be equal to 36. You plug it all back in to check, and it should work out perfectly for you. This one was a little tricky because we had that -3 up there. Remember, you do not change the number. So up here, right at the beginning of the problem, when my oppo was subtraction, I had to subtract a -3. That's something that you really got to make sure you do, is keep those negative signs in there if they start in there. Okay, any questions about this one? Alright. On this one, we have -7 times A minus 5 equals 400. This one's a little tricky. That's 40 and 40.
Oh, because you don't know what to add. What is the
This one's a little tricky.
No, these are
Alright,
negative.
y'all have a different one than I do?
No.
We have 40, you got 40. Oh, I'm sorry, equals 40.
Oh, yeah.
My apologies.
Plus 4.
It's always nice when you hear a murmur after you say something you have no idea why. Okay, I know the first thing we need to do is draw that line there because we have an equal sign. And now we can get into it. Solving this equation, at least for the first step, should be no problem at all. What's my first oppo that I'm going to do here? Bailey.
Addition.
Addition. I'm going to add 5 to both sides. Remember, we
Why are you
always
adding
do
5?
addition and subtraction first.
Why don't you add 7? Because it's first.
7 is being multiplied by 8.
Oh, I thought it was. Oh, it's. Oh, okay.
Okay, so right now we're going to add 5 to both sides. Those will cancel out, and we're left with -7 times A equals 45. -7 times A equals 45. Everybody should be with me so far on this. This is where it can get a little tricky. But I'm confident. I think y'all got it. What's my oppo that I'm left with now?
Oh, you have to divide.
I'm left with division. So I'm going to divide both sides by a number. Yeah, say it louder, Dallas.
-7.
There you go. We're going to divide both sides by -7, not just 7. Because remember, we can't change the number. So if I divide -7A by 7, I'll be left with A. And if I divide 45 by -7,
You get -6.428571429.
that's it. Thank you. 45 divided by -7 is going to give us a number, kind of like the one that's up on the screen here. Should be about -6.43. We'll round to the nearest hundredths place.
Oh, okay.
-6.43. What note's that?
What if you're at the whole number?
There we go.
Change it into a fraction.
Yeah,
Could change it to a fraction. You don't have to.
if you put this fraction, it'd be -45/7.
Okay. I like this one as a decimal because we didn't start with a fraction, so we really don't need to leave this a fraction.
Okay.
But if you wanted to keep it as a fraction, that's your prerogative. You feel free to do that. All right. Another one with some negative signs. That's what this slide's all about. Is introducing you to those negative signs. Right, here's another one. You should be able to go through that first step on your own, so I want you to do that. Get to the point where you're taking care of the first step of that equation, the oppo, that's addition or subtraction, and then we'll get back together and we'll talk about it from there. Do that on your own. Okay, if we add 7 to both sides, we should end up with c divided by negative 3 equals negative 5. Negative 12 plus 7 is going to be negative 5 if you plug that into your calculator. It's really, really important that we don't drop these negative signs. It's really easy to do because, let's be honest, negatives are not fun. Negatives are not fun, but they're part of life. You gotta keep them in there if they're already in there. All right, let's see. Tristan, what's my oppo now?
Multiplication.
Okay, and what am I multiplying by? Negative 3. Very good. I got to multiply both sides by negative 3. If I'm dividing c by negative 3, you can't change that number. Good call. So I'm left now with c equals, my line's not low enough, negative 5 times negative 3. Negative times a negative is a positive. 5 times 3 is 15. So c should be equal to 15 in this case. In order to check this, we can plug it back in there. So I'm going to put c in as 15. Let's see what happens. 15 divided by negative 3. We can do this on the calculator just so you can see it. 15 divided by negative 3 gives me negative 5. And then I subtract 7 after that, according to the problem. And that gives me negative 12. Is that what we're looking for? Yeah. So this one checks out. Outstanding. Look at that. Even the best of us forget to check our work. Oops. Okay, I believe this is the last slide. Okay. On this one right here, we have 2 minus 10d equals negative 35. This is kind of the one that Daniela was talking about earlier. Notice that our variable is second in line over there on the left side. How can we rewrite this to where it looks like it's a little bit easier to deal with? Somebody raise your hand and tell me that. Chris?
You switch the 2 being behind the 10 times d.
Okay, and what does that look like?
That would look like 10 times d minus 2.
Okay, close. Close. If we're subtracting 2 to minus 10d, and this is where it gets a little tricky. In situations like this, we will flip-flop 10d and 2. But look at the sign here. Is 2 positive or negative?
Positive.
It's positive. You're going to keep the signs with them. 2 minus 10d is really the same as negative 10d plus 2. And after we go through and solve this equation, we'll plug our answer into both 2 minus 10d and negative 10d plus 2, just to make sure that that's true. And I'll show you that that's true. But when you flip them like this, and the second one starts with a negative, or starts with the subtraction sign, you really just kind of treat that like it's the sign of that second number.
So we can rewrite it?
Oh, definitely. Definitely. So let's look at this one right here. Our first step is to subtract 2 from both sides. We know that because we have to do the oppo, that's addition or subtraction first. Plus 2 and minus 2 leaves us with negative 10d equals negative 35 minus 2 is going to give us negative 37. If you plug that in on your calculator, you get the same thing. All right? Now what's my oppo?
Division.
Division. What am I dividing both sides by? Positive or negative?
Negative.
Negative 10. Make sure we don't drop the negatives. Is equal to the quotient of negative 37 and negative 10. Let's use our calculator for that one. Negative 37 divided by negative 10. Whoops, not negative 0. Negative 10 is going to be 3.7, or 3 7/10. Let's stick with the decimal for now. Negative 37 divided by negative 10 should give you 3.7. That's positive. So let's plug in 3.7 and check our work with that first equation. We're going to see what 2 minus 10 times 3.7 gives us. And we're also going to see what negative 10 times 3.7 plus 2 gives us. I'm just plugging it back into, this one is our original, the one that was typed in. And this second one down here is the one that we rewrote. So let's see if it works. In our calculator, let's go to 2 minus 10 times 3.7. 2 minus 10 times 3.7. We get negative 35. So it works for the first way. And let's try it the second way too. Am I going too fast or anything like that?
No.
Okay. So negative 10 times 3.7 plus 2. Look at that. It's the same thing. So both ways of doing that work. Both ways of doing that are going to work out. And they're going to check out. That's awesome. We get double checks here. Now take a look at our opposite operations here. If we would have left it this original way, what would our first opposite operation have been?
Add it.
That would be subtract.
It'd be subtracting, because this is a positive 2 over here. To get rid of a positive 2, we have to subtract 2. Well, that's what we did right here. Then we'd be left with just negative 10 times d, like we were down here. And it would have continued going the same way we were doing. Always got to keep those signs the same. All right, last one. I want you to work on this one with your C partner. It's kind of weird looking. It's kind of weird looking because the E is on the other side. But I'm fully confident that you can do some problem solving and figure it out. Talk with your sheet partner. You check it. That's how you know. Finished and you'd like to check your work, it would be up there. If you have finished and you'd like to check your work, feel free to do so. And if you got it right, feel free to start on your homework. No. You don't have to raise your hand to check for me to come by and check because it's on the screen, so you can just check it off up there. If you do finish, if you did get it right, feel free to work on your homework.